Ever wonder how your phone just knows what you're about to type? Or how a self-driving car can actually see the road? Well, today we're pulling back the curtain on the different ways machines learn. And you know what? It's probably a lot more intuitive than you think.
I mean, think about it. How did you learn to ride a bike? You didn't just read a textbook, right? No, you learned from experience, from trying, from falling down, and from adjusting until you got it right. So, what if a computer could do the exact same thing? That is the big question right at the heart of machine learning. Okay, so before we dive into all the different learning styles that machines have, let's make sure we're on the same page. What does it actually mean for a computer to learn anything?
Think of it this way. The old school way to get a computer to recognize a cat would be to write a million lines of code with if-then rules. You know, if it has pointy ears and whiskers and fur, it's a total nightmare. It would never work. Machine learning just flips that whole idea on its head. Instead, we just show the computer tons and tons of cat pictures and let it figure out what catness is on its own. It's all about learning by example, not by a long list of rigid instructions.
So, how do we actually teach a computer using these examples? Well, the most common way is something called supervised learning. I want you to imagine a student who has a really helpful teacher, or maybe a huge stack of flashcards with all the answers already written on the back.
So with this method, the machine gets a massive data set where everything is already neatly labeled. We're talking thousands of pictures of cats, each one with the tag cat, or thousands of financial transactions, each one marked as fraud. The whole point is for the algorithm to learn the connection, the secret sauce really, that links the input to the correct label. That way, it can spot a new cat or flag a new transaction it has literally never seen before. And this supervised approach usually does one of two main things. First, there's classification. That's all about sorting things into different boxes or categories. Is this email spam or not spam? Is this a picture of a cat or a dog? It basically answers the question, what kind of thing is this? Then on the other hand, you have regression. And that's all about predicting a specific number on a sliding scale, like what will the price of a house be or what's the temperature going to be next week? It answers the question, how much will it be?
And believe me, you're using these all the time, probably without even thinking about it. That spam filter in your email? Yep, that's classification. A website giving you an estimated price for a house? That's regression. It's this invisible engine that powers so much of our digital lives. But here's the catch. You need a ton of high-quality labeled data, and creating that can be super expensive and take a whole lot of time.
So what do you do if you don't have the time or the money to label millions of cat pictures? This is where semi-supervised learning gets really clever. It takes just a small handful of labeled examples to get the ball rolling, and then it uses that initial knowledge to start making educated guesses and labeling the rest of that giant, unlabeled dataset all by itself. It's a really practical, smart middle ground.
Okay, let's take this a step further. What happens if there are no answer keys at all? I mean, no teacher, no labels, just a massive, totally chaotic pile of data. This is where unsupervised learning comes in, and this is all about finding the hidden patterns buried inside all that chaos. The goal here isn't to be right or wrong, because there are no right answers to check against. Nope, it's all about discovering hidden structures. It's kind of like being given a giant, messy room and just being told, hey, make sense of this. You might start by putting all the books together over here, and then all the clothes over there, and then maybe all the electronics. You're creating your own categories on the fly, and that's exactly what an unsupervised algorithm does. Now, it does this in a couple of really clever ways. The first is clustering, and that's that automatic sorting process we just talked about. It's like having your music library suddenly group itself into genres you didn't even know existed. Then there's dimensionality reduction, which is just a fancy way of saying simplifying, right? Like if you were trying to describe a car, you wouldn't list every single nut and bolt. You'd focus on the big things, the make, the model, the color. That's exactly what dimensionality reduction does for data. And this is just so powerful. Businesses use clustering to find new groups of customers they never even knew they had, finding people with similar buying habits. And you know how you can compress an image to make the files smaller and easier to send? That's dimensionality reduction right there, getting rid of all the unimportant pixel data to shrink the file. All right, let's shift gears completely. What if the machine isn't just sorting data, but it's actually doing things out in the world? This is the world of reinforcement learning, and it is all about learning by doing, and, well, by making a whole lot of mistakes along the way. So here's the basic loop. You have an agent, that's our algorithm, and it tries to do something in its environment. If it does something good, it gets a reward, like a point. If it does something bad, it gets a penalty. And over and over and over again, millions of times, it starts to learn a strategy or a policy to get the most rewards possible. It's a lot like training a dog with treats, but just on this massive digital scale. This is the stuff that's powering some of the most mind-blowing AI breakthroughs we're seeing. It's really the only way you could teach an AI to master a crazy complex game like Go, where the number of possible moves is literally greater than the number of atoms in the known universe. It's how a robot can learn to assemble a car, and it's how your favorite streaming service seems to know exactly what you want to watch next. So, there you have it. Those are the three main flavors of machine learning. You've got the student with the teacher, the lone explorer finding patterns, and the agent learning from trial and error. But out in the real world, things get even more interesting, because the most powerful AI systems often combine these ideas or use even more advanced techniques. Here are two of the biggest ones. First, ensemble learning. This is basically the wisdom of the crowd approach. So instead of relying on one single brilliant model that might have a blind spot, you combine the opinions of lots of different models. The errors of one model often get canceled out by the strength of another, and you end up with a much more accurate result. And then there's deep learning. This is all about building an artificial brain with many, many layers, which lets it learn incredibly subtle and complex patterns directly from raw data, like pixels in an image or sound waves. And just like our own brains have different parts for different jobs, deep learning has specialized models. CNNs are like the visual cortex, and they absolutely master images and video. RNNs are like the auditory cortex, great at understanding sequences like speech or music. And transformers, well, they're the powerful language centers that are powering the incredible conversational skills of models you've probably heard of, like ChatGPT. So we've taken a quick journey through all these different schools of machine learning. We had the teacher-led student, the self-taught explorer, and the trial and error apprentice. But what's the big takeaway here? Why does knowing the difference between all these things actually matter? Well, it matters because these 6 learning styles, supervised, unsupervised, reinforcement, and their more advanced cousins, they are the fundamental toolkit of modern AI. Every single time you interact with an intelligent system, it's using one or probably a combination of these very approaches to get its job done. There's a great quote that says these algorithms are the backbone of modern AI, and it is absolutely true. Each one is a specialized tool, and the real art and science of AI is knowing which tool or which combination of tools to use for which job, right? I mean, you wouldn't use a hammer to turn a screw. So the next time your email perfectly filters out a piece of spam, or you see one of those mind-bending AI-generated images, or you watch a self-driving car navigate a tricky intersection, you'll know the secret. It's not magic. It's one of these powerful learning methods at work, quietly shaping our world in ways both big and small. And that really leads us to the ultimate question. Now that we have taught machines how to learn, what are the most important things we should be teaching them to do? The answer to that question is going to define our future.